detailed timeline during those 7 minutes. If any one of them fails, we're toast.
This is beyond what we've done before. You have to pre-design it to work the very first time.
Every engineer has their gulp moment.
7 minutes of terror officially begins now. The spaceship slams into the Martian atmosphere.
The accuracy has to be lined up very carefully so that you're hitting it with the right amount of energy and exactly the right angle.
There's still a long way to go.
It's traveling 6 times the speed of a high-powered rifle bullet.
That would be like flying from LA to New York in 15 minutes.
10 times what any airplane can do.
First line of defense, the heat shield. It glows like the surface of the sun and reaches temperatures that could melt steel.
Our heat shield structure is what basically provides the backbone, and this material sitting on the surface is what stands between you and toast.
That protective material is only about as thick as a deck of cards. It's never been used on a Mars lander before, but there's always a first time.
There's over 100 jigsaw pieces that have to be very accurately assembled onto this shell in order to form a heat shield.
It's actually the biggest aeroshell ever built to go to Mars.
A bigger shell means larger drag forces. A tilted entry helps with control.
What that does is it essentially gives us wings. It gives us a lift vector that we can steer during flight.
This vehicle can essentially do what a surfer does when he's riding a wave. We have to be able to curl back and forth to manage where we're going to land.
It's all up to the computers now. The programs track tiny adjustments along the way so the lander arrives on target.
That's actually really the most novel thing, I think, Sky Entry.
This is the first time we've been able to steer a mission.
It's keeping track of how fast it's going and corrects itself.
And then bang!
We deploy a parachute. Our parachute is the largest and strongest supersonic parachute ever built, almost 65 feet in diameter. Half of a football field behind the capsule. It inflates, taking 65,000 pounds of force, and it decelerates us down to about 200 miles per hour.
Or over 300 kilometers an hour, still way too fast to land. The parachute is cut off, computers trigger the reverse rockets, and the lander approaches near zero velocity. This is when things get even more hairy.
It's kind of scary, it looks complicated, and it's cool.
The Sky Crane comes next.
The Sky Crane concept definitely raised a lot of eyebrows.
It's a thrilling piece of mid-air choreography created by engineers and executed by computer programs.
We separate the rover from the jet backpack, lower it on 3 ropes, and slowly descend to the surface.
Touchdown needs to be as light as a feather.
It's coming down and actually lands on the same wheels that it drives around on, which is amazing.
We detect that touchdown, cut those ropes, our jet backpack flies away, and then we're done.
The landing engineers have done their job. Now, all eyes are on Curiosity the rover to do hers.